All right, let's jump right into this explainer and build a really clear, structured mental map of the incredibly complex world of backend APIs. Look, if you've ever felt completely overwhelmed by the sheer number of acronyms out there, REST, SOAP, JSON, XML, trust me, you are absolutely not alone. It's a total alphabet soup. So today, we're going to treat the API landscape like unexplored territory. By the time we wrap up, you'll have a complete visual map to navigate the whole thing like a pro.
Here's our roadmap for this explainer. First, we'll tackle the heavyweights, REST versus SOAP. Number 2, API timing, specifically sync versus async. Third, we'll look at routing with single and multipath APIs. Fourth, API scopes and accessibility. And finally, how to read the map itself, API documentation. Okay, let's start with the absolute largest continents on our API map, the major architectural styles, specifically REST and SOAP. When you look at the top tier of APIs, you'll immediately notice the massive market dominance of REST. It commands a whopping 80% of usage, while SOAP handles the remaining 20%. So together, these two make up roughly 90% of all backend communications. Because REST is so overwhelmingly dominant, it's pretty much the default. But understanding exactly why we have this 80-20 split is absolutely crucial for making smart engineering decisions.
The biggest takeaway here is the stark contrast in their fundamental nature. SOAP, which stands for Simple Object Access Protocol, is exactly that, a highly strict, heavyweight protocol. Think of it like filling out a highly regulated government form. You literally have to fill it out perfectly, or it gets completely rejected, no exceptions. REST, on the other hand, stands for Representational State Transfer. And actually, it's not even a protocol. It's a lightweight, incredibly flexible architectural blueprint. It gives developers design guidelines rather than rigid rules.
And because of that fundamental difference in flexibility, their features contrast sharply. Just look at the data formats. REST lets you use pretty much whatever you want. JSON, XML, HTML, even plain text. That makes it super lightweight and extremely fast. SOAP, however, is totally uncompromising. It strictly uses XML. And why is that? Well, it comes down to security. SOAP provides heavy-duty end-to-end WS security, whereas REST just relies on standard SSL. So if you're building a highly sensitive banking app, you absolutely want that rigid SOAP structure. But for almost everything else, the sheer speed and flexibility of REST is a hands-down winner. Moving right along to section 2, let's see how traffic actually moves through this territory based on timing. We're going to compare synchronous and asynchronous APIs. So you can think of synchronous APIs kind of like a traditional phone call. You dial, you wait on the line, and you expect an immediate answer. You can't really go do anything else until that call is over, right? Asynchronous APIs, though, are much more like sending a text message. You shoot off the request, you don't freeze up waiting for the answer, and you can go do other tasks and just process the response whenever it eventually shows up. Let's ground this in a real-world scenario. Say you need to fetch a quick list of enrolled users for a web dashboard. That requires a synchronous response. The user clicks View, and they expect to wait that fraction of a second for the list to just pop up immediately. But what if you're uploading a massive 4K video file that needs heavy server-side processing? If that was synchronous, your entire app would literally freeze for 10 minutes. So instead, it uses a delayed asynchronous response. It accepts the file, lets you keep browsing, and just pings you when the processing is finally done. Okay, section 3. Now let's explore how we actually ask the server for what we want using routing paths. We'll look at single path versus multipath APIs. Imagine you're at a massive hotel restaurant buffet. Do you request all your food? You know, the pizza, the pasta, the pastries from a single counter all at once? Or do you have to physically walk to separate stations, asking the pizza guy for a slice, and then walking all the way across the room to the pasta station? This is a great way to understand the difference here. Notice how GraphQL essentially acts as that single path counter, where you get everything at once. It provides just one endpoint, so in a single API call, you can ask for a user's ID, their name, and their past orders, all together in one go. REST, however, relies on multipath routing. You have to hit a specific user's path to get the user data, and then make an entirely separate trip to the order's path just to get their history. So REST is very neatly organized into separate folders, but GraphQL saves you from making those extra trips. That brings us to section 4.
We need to map out where these APIs actually live and who exactly is allowed to use them. API scopes and accessibility. Geographically speaking, APIs operate in completely different spheres. Web APIs travel across the internet. These are the REST and SOAP services we just talked about, used for things like, say, logging into a website.
But there are also local APIs, which communicate entirely within your device's operating system without ever touching the web at all, like your OS checking the system time. And zooming in even further, we have program APIs, which is basically code communicating internally with software libraries. For example, a Java program using a built-in print command.
From an accessibility standpoint, specifically looking at web APIs, there are strict borders. APIs can be entirely public, literally open to the world, like Google Maps, allowing anyone to embed their location data. Or they can be restricted to partners, like an airline securely sharing live flight data, but only with specific booking sites like Make My Trip. Or finally, they can be kept entirely private, locked down so only internal company teams can use them, much like Amazon's proprietary backend inventory systems.
And finally, Section 5. Let's learn how to read the legend of our map so you can actually test these systems. It's time to talk about API documentation. When developers hand you API documentation, you're looking for 5 crucial elements so you aren't just flying blind. You need the base URL, which is the main address, and the specific endpoint path that gets appended to it. You absolutely have to know the HTTP method. Are you getting data or are you posting it? You need to know the exact format of your request payload, your input data, and finally, you need the expected status code so you actually know for sure if the call was successful.
Now developers might share this blueprint using a few different formats. Sometimes you'll encounter older static formats. Think Word documents, Excel sheets, or PDFs. And yeah, those require you to manually copy and paste every detail into your testing tools. But thankfully, most modern engineering teams are heavily shifting toward dynamic documentation platforms like Swagger, Confluence Wikis, or Postman collections.
Swagger, in particular, is an absolute game changer. It's incredibly popular because instead of a dead text document, it generates a live interactive web page. You can read the specs, see the required input formats, and literally test the API calls directly inside your browser. And the best part, it's auto-generated directly from the developer's source code, which ensures the documentation is perfectly in sync with how the application actually behaves in real life. So, behind the scenes, how does all this magic happen? Well, developers use specific frameworks to expose their raw backend logic. Think of these as a critical bridge. In Java, they use libraries like JXRS or Spring MVC to magically convert raw code into those testable REST endpoints. And if they're using SOAP, they rely on generators like JAXW. These tools are the vital translators, turning raw code into the usable APIs we interact with every day. We've mapped out some incredible territory today, and you are now fully equipped to navigate these architectural styles with total confidence. So I'll leave you with this provocative thought to explore with your own engineering team. Which of these styles are you relying on day to day? And are you overcomplicating a lightweight REST task by swinging a heavy SOAP hammer? Thanks so much for joining me for this explainer. Stay curious and keep exploring.